everyone. Here we go. We're in our fourth video of the series. And today I want to talk to you about a different way to think about stress. We're going to be talking about stress, depression, anxiety, and natural solutions to clear those up through optimized intestinal health. This is probably the most exciting of all of the series, and I hope you really enjoy this. We're going to be looking at the increased prevalence of depression and anxiety, and I'll be sharing with you evidence of how our stress and brain health in general is controlled and adjusted by the microbiome that we've been talking about all along in this series. I'm going to show you images and data that are the results of hard work by literally thousands of scientists. And on each slide, you're going to find a link. And that's going to help you see whose work it is. It'll help you to investigate further if you want to know more information. And I want to strongly encourage you to jump in, read about this, investigate it, and share at least what you're learning today with your family and loved ones. In the first 3 videos of the series, I let you in on the news that the intestinal microbiome is now accepted as our newest endocrine organ. And if you're new here, the word microbiome refers to all the bacteria and other flora inside your intestines. It's the species themselves, the life forms, and the house that they have built to live in. And all of that together is considered our newest recognized organ, but it's a very powerful organ. So, and the word endocrine really refers to a place where hormones are produced, but you're going to see that it's a lot more than hormones that are being produced in the microbiome. And, you know, before all these amazing discoveries were made, we thought of our body's hormone system as being composed of a list of glands. And here are some of them on this slide. And each one of those glands produced particular hormones that control specific functions and the coordination of our body and our mind. But now we know that the microbiome in our intestines produces a wide array of hormones, neurochemicals, and other hormone-like chemicals that are all released into the bloodstream and act to direct the actions of all of the other endocrine glands and the major organs, our brain, and really all of the systems of your body. This biochemical capacity of the microbiome is based on what species live in your microbiome, and especially on the diversity of the species. And diversity means the more the merrier, okay? So the more species you have, the healthier you're going to be. And, you know, if you think back in the first video, we talked about how to create a strong immune system. And, and if you want to know more about that, go back and watch that first video. In the second video, we got into more about how to balance our hormones. And in the third video, we discussed exactly how to achieve healthy weight by optimizing intestinal health rather than dieting. So here, you're going to see, this is just a diagram of what's going on inside of our intestines. So inside we have the microbiota, that's the different species that are all mixed up together, and they live there, and they in a very big way coordinate their efforts. There's cross-species communication going on in our gut, and there's so about 160 species in a healthy person, and they are coordinating their efforts as a team to produce all manner of metabolites, of products, basically. They're making hormone-like metabolites, they're making short-chain fatty acids, They're making tryptophan, which is a neurotransmitter precursor. So the body uses that to make neurotransmitters. The microbiome can also produce really every single neurotransmitter we know of. The microbes are producing every type of signaling function, every type of molecule that produces a signal that we know of. And it's all happening in the space or the lumen of the intestines. And what happens is the molecules are produced and then they're transported across the barrier, the epithelial barrier and mucosa into the blood, and then it's transported to the target tissues and organs, including to the brain. So this is a look at what everybody's getting really excited about, and that is the gut-brain axis. There is a ton of research that's come out just recently telling us all about this. And it's generally accepted that a diverse and relatively stable gut microbiota is essential for normal gut function and normal brain function by contributing the molecules that we need for optimal signaling along the gut-brain axis. And all of this is essential for our good health. Think of the term gut-brain axis as meaning a two-way communication channel between our gut and our brain. As you can imagine, intestinal dysbiosis has a huge negative influence on the gut. Imbalances of our microbiome leads to inappropriate gut-brain axis signaling, which can then result in a long list of potential disease states. On the other hand, stress at the level of the brain and the spinal cord can affect gut function. So it goes both ways. And that can lead to serious difficulties in flora balance. The flora can get very imbalanced. So some species can completely die if we are stressed in our central nervous system. What I'm saying here is that when we get stressed out, we get major signaling problems from the gut to the brain and from the brain to the gut. Works both ways. These signals travel by way of the enteric nervous system, and that's all the nervous system that's around our intestines, and the vagal nerve. The vagal nerve travels all the way up into the brain. It's a major brain signaling nerve. Our mood can actually kill some of our most essential species and can have a devastating effect on the cross-species communication amongst those microbes that are living inside of us. So this is how our stress level or negative mood can have a direct negative effect on our immune system, our weight, our hormone balance, and it can also affect our cardiovascular health, and directly it can cause changes to the heart and to the vessels, and other stressors such as nutrient deficiency, poor diet, medications, and infection can also alter the behavior and the stability of the flora that are living in our microbiome. So now let's take a look at our psychological health. What do we know? I want to start by focusing on children and young adults. Ever since the 1930s, young people in the United States have been reporting feeling increasingly anxious and depressed. And no one knows exactly why until now. So one of the researchers who's done the most work on this subject is Dr. Jean Twenge. She's a social psychologist at San Diego University, and she's published a book and several articles on this topic. And the underlying story that she's giving is a rather negative one. As a whole, over the years, her work has told us that modern life is really not good for our mental health. So here are the trends that showing the gradual loss of memory, concentration, and ability to learn, and the lack of ability to sleep that's happened in 12th grade children between the years of 1982 and 2012. And all of these symptoms are associated with depression. So does the trend have anything to do with teenage angst? Does it have to do with attention deficit disorder? Maybe suicide rates, homicides? So after publishing her study with high school children, Dr. Twang asked the question, does depression trend get better with maturation? So here's a look of Dr. Twang's next research. And what she found was the answer was no, it does not. Here's the trend of depression from the 1930s to 2010 in college students. The increase in depression is not just happening in children. Ask the same question about the same points in their lives, more and more adults are over time experiencing worse and worse symptoms associated with anxiety and depression. So here, what I'm showing you is, and by the way, this image is brought to you by the courtesy of Blue Cross Blue Shield Insurance. So this has to do with their insured population. And what it shows us is that the change of diagnosis rate for major depression, and it's comparing it over time in different age ranges. So we've got from 12 to 17 in the first two bars, 18 to 34, 35 to 49, and 50 to 64 years of age. And what I can tell you about this is the diagnosis rate was tested in both 2013 and 2016. And so the orange is the 2013 rate and the blue is the 2016. And what we know is that in the United States, over 9 million commercially insured individuals have been diagnosed with major depression. That is not going to reflect the actual numbers of people suffering. That's going to reflect those that went to a doctor, put it under their insurance, and reported this. It's thought that there's a lot more people that are suffering that are not reporting their symptoms and not going to the doctor for it. So here's what was found. Between 2013 and 2016, the diagnosis of major depression rose dramatically by 33%. This rate is still rising even faster right now, and it's especially amongst the millennials, who have suffered an increase of 47% of diagnosed major depression. And in the adolescent group as well, they've increased 47% for boys and 65% for girls in that 12 to 17-year-old range. Women, adult women, are diagnosed with major depression at higher rates than men. It's a 6% rate for adult women and 3% rate approximately for men. The researchers that did this work noted that people diagnosed with major depression are nearly 30% less healthy on the average than those not diagnosed with major depression. And this decrease in overall health translates to nearly 10 years of healthy life lost for both men and women equally. 85% of the people who are diagnosed with major depression also have one or more additional serious chronic health conditions, and nearly 30% have 4 or more other conditions going on in their body. People diagnosed with depression use healthcare services more than other people. And this obviously was in the commercially insured Americans. But in general, they're using healthcare services more so. And it actually results in twice the cost of medical care for people that are depressed. So we have an increasing number of people that are highly depressed and doubling the cost on our health, for healthcare. Personally, I've seen evidence that in the younger people, there could be some effect by gaming, social media, and a general addiction to electronic devices, okay? And this is not just in children, this is in adults too, but I think particularly in children, there's a deep effect. And the devices are causing an increase in social isolation. It definitely causes mood issues in many of the teens that I see. And it causes a decreased ability to achieve deep sleep in both children and adults. And also it causes lowered immune system. And what the data is showing us is that when people are on their electronic devices a lot, there is statistically a more frequent chance of getting infections, colds, flus, other types of infections. However, I also know that if someone's up late at night, they're more likely to take in sweet or starchy, simple carbohydrate food. And that also will seriously impact the balance of the microbiome, the species that are living inside of them. And this, along with the lack of sleep, negative mood, in turn, is going to cause devastating changes to the level of hormones and neurotransmitters being produced in the body. And eventually, it's going to lower the immune system and lead to poor health. So anxiety is also a big problem. And the problem of depression and anxiety is not only happening in the United States. In England, there's been a governmental call for an urgent review of workplace practices after the anxiety and depression levels and extreme anxiety levels have been shown to have risen by 1/3 since 2013. The call for action was instigated by the United Kingdom Council for Psychotherapy and follows new research showing the rise in anxiety to be most extreme in part-time workers who have seen extreme level changes, well over 1/3 in their population. So we're still at the very early stages of understanding the complex communication systems that are happening between our gut bacteria, immunity, behavior, but it's now established that certain bacteria within the human gut play a fundamental role in the ability to produce molecules with neuroactive properties that can impact the brain physiology and behavior. And so this is just a short list right here of some of the species that are producing serotonin and dopamine. But every single neurotransmitter can be produced by at least one species in the gut. And I don't actually, of all of the lists, you can go onto this website and take a look. But what we see is that there are, I would say, looking at the list and studying it myself, there were at least 4 species so far that have been found that can produce each and every neurotransmitter. It's pretty amazing. So the neurotransmitters, of course, are affecting how we think, and we'll get into that in just a bit. So we also know that suicide is very much on the increase. This is looking at suicide over the years of between 1999 and 2014. So the dark green is the earlier and light green is the darker. And we're seeing at least well, somewhere between 25 and 40 some odd % increase in suicide in most age groups. And look at the adults, the working class, basically 45 to 64 years of age, their suicide rate has increased tremendously. So our brain chemistry is based on a delicate balance of neurotransmitters. When someone experiences high anxiety, they're usually going to have an imbalance in the 2 neurotransmitters, glutamate and GABA. GABA is GABA-aminobutyric acid. There's going to be too much glutamate and not enough GABA. So that's what's going to happen if there's high anxiety. Glutamate is one of your primary excitatory neurotransmitters. It has many important roles, like stimulating your brain cells so you can talk, think, process information, learn new information, pay attention, store information in both your short and long-term memory. As a matter of fact, studies suggest that the more glutamate receptors you have, the more intelligent you are. High levels of glutamate receptors are correlated with superior abilities in learning and memory. Unfortunately, they also correlate with an increased risk of stroke and seizures. So if you don't have a lot of them, don't worry. But some of the practices and the additives that are in our foods and medications actually can decrease the number of our glutamate receptors. And although it's not been proven, the supposition is that when you lose your glutamate receptors, you actually lose IQ. Although glutamate is one of the most abundant neurotransmitters found in the brain, it exists in very small concentrations. So if the concentration level rises, then neurons become too excited and don't fire in a normal manner. Glutamate becomes an excitotoxin when it's in excess, meaning it overstimulates brain cells and nerves and results in neurological inflammation and cell death. So this is probably the main mechanism that why older people lose their brain mass. An excess of glutamate is a primary contributing factor to a wide variety of neurological disorders like autism, Lou Gehrig's disease, ALS, Parkinson's, schizophrenia, migraine, headaches, restless leg syndrome, Tourette's, PANDAS, fibromyalgia, multiple sclerosis, Huntington's chorea, and also in unexplained seizures. It's also found to be associated with atrial fibrillation, insomnia, bedwetting, hyperactivity, obsessive compulsive disorder, and bipolar disorder, the anxiety disorders. There's a whole raft of them, I won't list them. And STIMs, which is repetitive self-stimulating behavior like rocking, pacing, body spinning, hand flapping, repetitive body movements or movement of objects that are commonly, this is commonly seen in autistic children. And it's also associated with an increased risk of stroke. So too much glutamate can increase our eosinophils, and that's a type of white cell which causes an increase in inflammation in the body. And it can impair blood vessels that leads to migraines and blood pressure irregularities. So this might be partly why some people have unstable blood pressure. And it can also impair other areas of the brain, like the hypothalamus, the hippocampal neurons, Purkinje neurons, which also affect speech and language. Something else I need to tell you about, a lot of people are dealing with mercury toxicity. It's very, very common. And in this office, when we test people for heavy metal toxicity, we see mercury a lot. And mercury in the body becomes more toxic in the presence of high levels of glutamate. Excessive glutamate also makes cancer cells proliferate. And so it increases tumor growth and survival. And that's the connection in between stress and growing tumors. All right, so that's why so many people note that when they're trying to fight cancer, they do so much better and they regress more easily when they are practicing such things as mindfulness, meditation, prayer, qigong, all these practices that are very calming and soothing, and getting plenty of sleep really makes a huge difference for those people. Let's see, high levels of glutamate also increase the survival of unfriendly microbes in the gut. So the bad guys are able to live in the presence of glutamate and overgrow, whereas some of the good guys can't grow in the presence of glutamate. It actually kills them. And when this happens, that's going to contribute to excess acid production or heartburn, GERD, that sort of a thing. And too much glutamate can also lead to too much acetylcholine. And that has its own stimulating effect and also puts one into a perpetual state of like being in the sympathetic nervous system. So you're perpetually stressed out. And so it's going to cause high levels of anxiety, fear, insomnia, restlessness, nervousness. Really, I've only scratched the surface here on glutamate, but you can see that high glutamate is a major issue. So what about GABA? GABA is short for gamma-aminobutyric acid, and it's your primary inhibitory neurotransmitter. Its role is to calm us, to calm the brain, slow things down, and help us to relax. One of the ways that it assists in this process is by increasing alpha wave production in the brain. It's also vital in speech and language. GABA puts the pause or the space in between words when you speak. The brain uses it to support sensory integration, and without adequate GABA production, our conversations would consist of lots of run-on sentences, slurred speech, or loss of speech, and we would have trouble with comprehending language in general. So, GABA is your intestinal tract is packed with GABA receptors, and it's critical for the contraction of the bowel, so for making bowel movement. Insufficient levels of GABA can result in abdominal pain, cramping, constipation, and impaired transit time. It also supports healthy levels of immunoglobulin A, and those are the antibodies that your gut produces to protect itself and other mucus linings from harmful invaders. That's our main, it's our main mode of protecting ourselves from what's coming into our mouth. Basically, the outside world coming inside of us, that is how we protect ourselves. So without enough GABA, we don't get protection. Insufficient levels of GABA result in, as you can imagine, nervousness, anxiety, panic disorders, aggressive behavior, decreased eye contact, and antisocial behaviors. It is associated with attention deficit disorder, problems with focusing one's eyes, like that's seen in autistic children. When both eyes are focused inward, sometimes the autistic children are focusing their eyes in, like almost cross-eyed. And, or their eyes may waver back and forth and not hold attention. It can also cause chronic pain syndromes. You know, I can go on. There's so many more symptoms it can cause, but you can imagine that anything that causes increased excitation and difficulty with the nervous system in that way are going to be seen when there's not enough GABA in the body. Low levels are also associated with heartburn, as I mentioned before, or GERD. GABA is needed to regulate the lower part of the esophagus, and it turns out that GABA may be needed in addition to proper levels of stomach acid to be able to stop heartburn. Let's see. I'll also mention that low levels of GABA play a vital role in alcoholism and in drug addiction and cravings for sugar and carbs, as all of these substances will temporarily and artificially increase GABA. So that's why some people are really unconsciously drawn to use these substances. However, these substances are also depleting the neurotransmitters, so they're going to perpetuate the problem. GABA is found in every area of the brain. The hypothalamus contains probably the highest concentration of GABA, and it has the highest concentration of GABA receptors as well. So it's vital for its many functions like regulating sleep, body temperature, appetite, thirst, sexual arousal and desire, the action of the pituitary, actually the whole HPAT axis. And if you watch the second video of the series, I talk about that in more detail. And it affects the autonomic nervous system as well. So the primary role of the hypothalamus is to maintain homeostasis or balance, biochemical balance throughout the body. And without enough GABA production, this is just not going to happen. Like all neurotransmitters, GABA and glutamate play a vital role in regulating the autonomic nervous system. And that is our main stress response system. It's maintaining the balance between the what we call the sympathetic and parasympathetic nervous systems. And if you're feeling a little bit nervous right now, all you have to do to go from sympathetic to parasympathetic is take a deep breath. Blow out your air. Breathe in, and the parasympathetic will kick in, and you'll feel a little bit calmer, perhaps. So that's some of that going on. GABA is the one that allows you to stay calm and not spin out. So they are, so the depletion of GABA is going to keep us from going into the calm and centered of the parasympathetic mode. And it can be a major contributing factor to all kinds of autonomic nervous system disorders, like adrenal fatigue, insomnia, chemical sensitivities, chronic fatigue, panic attacks. There's a long list. And maintaining sufficient levels of GABA is crucial in the recovery of these conditions. And so I'll go back to the microbiome. Some of the species of bacteria convert glutamine into glutamate. And if one has an excess growth of these kind of bacteria, that can contribute to excess glutamate in the body. So that means that person's going to be very, very nervous because of who is growing inside of their gut. And additionally, some gut bacteria eat glutamine. So people who have, for instance, SIBO, it's a small intestinal bacterial overgrowth, SIBO. People that have that, they can have an overabundance of glutamine, and any glutamine in their diet will actually feed glutamate, and the increased production of glutamate can cause increased proliferation of the SIBO itself. So you see it's cyclical. The bacteria are producing glutamine, it's turning into glutamate, they're getting very, very nervous, and it gets worse. And the toxins from a person with SIBO, from those particular bacteria, can, as you can imagine, the toxins themselves are a stress on the body, and that also can include more glutamate. So that's one of the reasons that people with SIBO tend to be very, very hyper. And there's a lot of people with SIBO that are undiagnosed. They don't realize it. They have an overabundance of certain bacteria, and it's causing them to be very nervous. So here's some of examples, some more examples of neurotransmitter-producing or neurotransmitter-releasing bacterial strains. If you go into some of the research that I'm citing for you, you're going to see a lot of species that are being pointed out as the producers of these. Let's see. So let me get you into some of the research that's been so exciting for me, and what I've been learning about in preparing this talk for you. This is a slide out of Dr. Curtis Huttenhauer's laboratory at Harvard School of Public Health, where attempts are now being made to map out all of the microbiomes of a healthy body. And the idea they have is to discover the typical groups or families of flora that are found in healthy people on the mucosal lining of different sites around the body. And we want to know, basically, we want to have a map of how these bacteria organize themselves. And the lower right-hand side, you're seeing the attempts to actually map out and look at what happens in the dynamics of how the map changes when a person is not well. And in the upper left-hand corner, you're going to see that they've listed some of the major species from the mouth, the skin, the gut, and the vaginal space listed here. So despite the emphasis on the major species, we also know that besides for these major species that are listed, there are minor species that are very, very important. And some of the minor species are creating like a magnetic resonance in the gut that the major species alone cannot produce. And there's something about the magnetic resonance of the gut that is very, very important. There's some great work going on in Dr. Higa's lab in Japan, where they are looking at this resonance, and they see that if you just have the good guys, the major species, you do not get this resonance in the gut that's associated with good health. But if tiny amounts of disease-causing bacteria are added to the mix, the resonance shows up. And by the way, this magnetic resonance is the same resonance that's measured from live springs, like water springs on the earth, when the water is coming from very deep areas. That water has a magnetic resonance to it, which is exactly the same as what we have in our own bodies. So very, very exciting research going on. And here I'm going to show you that this study, I really love this study. It's a great study. In depression, we know that there's a decrease in the diversity of gut microbes, while there's an increase in the inflammatory cytokines. And cytokines are the molecules that happen when we have inflammation. So these investigators looked to see if the inflammation in the gut or the brain, inflammation in the brain, was the cause of depression. And what they found was that the intestinal microbiota influences brain chemistry and behavior independently of the brain and nervous system, independent of gastrointestinal neurotransmitters, and independent of inflammation. Instead, it was the intestinal dysbiosis, or the imbalance of the growth of the flora, that was responsible for the depression. This means that dysbiosis, or imbalance of gut flora, might contribute to many different types of psychiatric disorders in patients with or without bowel problems. So there may not be any symptoms, but still what's happening in the gut is affecting the brain. Not only that, as we know, depression is associated with a hyper response of the HPAT, the hormone axis. And this hyper responsiveness was completely reversed. And that's in this paper, you'll read about that. It was completely reversed in very highly depressed, high anxiety mice by treating them with one flora, one species, and that was Bifida infantis, which happens to be one of the predominant bacteria in infants and is a probiotic we often use in this office. We use it whenever we do a biofilm turnover. And I described biofilm turnovers, or being able to create a new microbiome, in the third video. You might want to listen to that. So we can actually recreate the biome in people that need to have that. So it's very exciting what's happening with the Bifida infantis, because that particular species is one of the ones that we get when we're first born. It's a very, very important species. And maybe that's why the, little babies are so happy generally, unless they're sick. I'm also going to show you, I'll give you this. This is some other work. These are all studies that are being done to show us that maybe in the future we're going to have anti-anxiety, anti-depression probiotics. So in the first bullet, you're seeing that Bifidobacterium infantis has been shown to, in people that have irritable bowel syndrome, to alter the ratio of the pro and anti-inflammatory cytokines in the body, in the blood actually. So it's decreasing inflammation right at its root. And we also know that if there's dysbiosis in the gut, Bifidobacterium in general have an amazing calmative effect and are addressing some of the, especially the neural functions in the body. And we also know that Lactobacillus rhamnosus have anti-anxiety effects in animals. And it's actually acting by affecting the GABA that we just talked about. So here's another publication that I thought I had to show you, because it's talking about how puberty, okay, so in puberty, we have, it's the beginning of a period of dramatic physical, hormonal, and social change. And it's showing that the higher levels of stress hormones that happen in individuals going through puberty actually cause slower maturation. Now, and what this paper is looking at is showing that that slow maturation from stress can be reversed through the use of probiotics. Now, this study was done in adolescent rats, but it has yet to be repeated in adolescent humans, but maybe I'll try it on my own. So next, I want to talk to you about food. We're going to be getting in and out of what we're actually putting in our mouth, but I think it's fair to say that you are what you eat. We've heard it for years, and there's no doubt that the microbiota that's responsible for our happiness, our weight, hormone balance, and the health of our immune system, our healthy heart and circulatory system, our healthy brain, and even our ability to have happiness and be successful in life, is due to what we eat. What we eat is how well we can feed our microbiota. So let's get into a different topic. I want to talk to you a little bit about serotonin and dopamine. And we'll start with serotonin. Serotonin is the most widely studied neurotransmitter in relation to psychiatric illness. It's produced from tryptophan, and tryptophan is produced by the microbiota in your intestines. And serotonin is playing a key role in multiple processes in your body. It's very important. We don't have enough time to actually even list all of the processes that serotonin is a part of, but I will tell you that only a small portion of the serotonin is found in the brain. Over 90% of it is found in the GI tract. And most antidepressants currently marketed work by increasing serotonin levels. Those are SSRIs, or serotonin uptake inhibitors. And so they're basically keeping the body from getting rid of our serotonin, and that raises the amount of serotonin. And by the way, when those medications are taken, it gives us an imbalance between serotonin and dopamine. So the body will read that as lots of serotonin and not a lot of dopamine, and that's a problem as well. So most, there's actually several species of the gut microbiota that have been shown to produce serotonin, and there's more being found. So it's something that is widely done in the gut. But also the Bifidobacterium infantis that I mentioned before, this is my neurotransmitter baby doll. It's reported to increase levels of serotonin precursor tryptophan. And it's been shown that if you give this species and allow for the tryptophan that it produces to be introduced into the bloodstream of rats, it has a very direct antidepressant activity. Okay, so that hasn't been done in humans, not on purpose quite yet, but that tells you what's going on with the research. So most know that serotonin is produced in the gut, but as I mentioned before, 90% of it is produced in the gut. That's pretty amazing. We thought that it was a brain chemical. And so it turns out that this may have more to do with the signals that are coming from the gut to the brain than we realized in the past. And we still don't know much about that. But serotonin alters mood and controls the parasympathetic nervous system. It controls our ability to sleep and alters, it controls our ability to relax on all fronts. It also controls gut motility, digestion, and it has a large control over the gut to brain axis in ways that we don't really understand yet. We know through other studies that depression is often preceded by gut issues, and it's also strongly associated with the use of antibiotics. So you can see the connection there. The antibiotics are killing the bacteria, and afterwards the prevalence of depression is greater. Another reason why probiotics are very, very appropriate for when we're using antibiotics or after we use antibiotics. I want to tell you that both the depression and anxiety can come in a response to food poisoning as well, and act as a trigger. So the food poisoning can trigger low serotonin and low dopamine, and also can trigger low thyroid imbalances. So the gut also controls dopamine, and it turns on the reward pleasure center of the brain. So it helps you feel satisfaction. And low dopamine has been shown to be associated with addictions. In order to, you have to have dopamine in order to perceive pleasure, all right? So without sufficient pleasure or reward, the mind doesn't get enough motivation to get things done. So those with low dopamine get less pleasure from, say, going out with friends, reading a book, playing with children. Any kind of activity that had been pleasurable will not be, than those with normal amounts of dopamine. When you get depressed and anxious, dopamine levels go low, and then it's impossible to perceive that reward that you may be looking for. This is when a person wants to isolate them, curl up with the YouTube, hide away from the world. You don't want to be with people. The person with low dopamine is going to start thinking in a very negative fashion, and there are signs so those are the signs that you're going to have that dopamine is low. They may even have an inability to achieve orgasm, whereas the opposite is true of somebody with high dopamine. They will have increased libido, increased need. And now, so you can imagine that the low dopamine is creating a negative food, and so that's affecting what species can survive in our gut. So we have, here I have a list of biological compounds that address depression and anxiety. And this is, a pretty basic list here. So we're starting to look at, what are we going to do? We need clean, nutrient-rich food. This is very basic and ought to be enough in a perfect world. We may need vitamins, extra nutrition, especially the B vitamins and the antioxidants. We may need additional trace minerals, especially if the soil where our food is being grown is depleted of the minerals. We might need probiotics. We can get those fermented foods. We can talk about that in just a bit. We can use prebiotics and fiber. But the main piece I want to talk to you about here is the nutrition. I can tell you that the nutrients that one person needs can be amazingly different than the nutrients another person needs. And one of the things that I do here in this office is I help people determine what nutrients are going to be best for them and what's going to work best to help them balance their own blood chemistry and have a balanced microbiota as well. Now, the microbiota are producing a lot of nutrients, but some people need to have more than what we can produce and what we can eat in our food. So, You know, in that last slide, we talked about clean food, vitamins, minerals, so, you know, the basics of what we need to be healthy. And the probiotics, fiber, prebiotics and such, you know, it's very, very important that we, that the food we eat be safe for our body, and it's a powerful form of medicine. Ann Wigmore had made this quote, and I really felt I needed to share this with you. The food you eat can either be the safest and most powerful form of medicine or the slowest form of poison. Great lady she was. You know, and I have to say that the balancing of the neurotransmitters that good food and good nutrition can do for you, and the replacement of good bacteria, is probably why when I take people for a detoxification, I take people for a week every year for a detox, and we're all so amazingly happy at the end of the week, because during that week, we're taking in really healthy food. We're taking in raw and fermented foods, and you know, it doesn't have to be just salad. We have crackers and breads and soups and sauces, but they're all made of fresh, raw, better than organic food that's grown on super healthy soil. So it's now generally accepted that a stable and diverse gut microbiota is essential for a well-balanced neurotransmitter production and appropriate signaling along the gut-brain axis. A healthy microbiome is essential for our health. On the other hand, let's see, if we have imbalance, like intestinal dysbiosis, it's going to adversely affect our gut physiology. And it's going to lead to inappropriate gut-brain axis signaling. It's going to result in depression, anxiety, and in many, many other disease states. Now remember that the signaling goes both ways. Stress at the level of the central nervous system can turn around and affect the gut function and lead to imbalances and perturbations in the microbiome. So I'm going to teach you how to rebuild a healthy intestinal microbiome. All right, you have some of the information, go over it right now. And this is my gift to you. There's 3 simple steps to building a healthy microbiome. First step is to increase your intestinal flora with probiotics through supplementation of a rotation of wide spectrum probiotic formulas containing well-tested strains that are effective at colonizing the human intestine. Now, I say a wide spectrum, but sometimes what I do is I use very specific flora, like that Bifido infantis. That's one that is going to come into play if someone is reporting that they're depressed. There's other species that I mentioned in the 3rd video that I'm going to use if there's weight issues. There's a whole long list of species that we might use for immune system challenges. Okay. Another method that you can rebuild your healthy microbiome is to increase your intake of live fermented foods, such as Rejuvilac, kombucha, seed cheese, sauerkraut, pickles, kimchi, tempeh, miso, or kefir, or yogurt. Many of these are very easy, they're fun to make at home, and they cost very little in time or money to prepare. So the second step is widen the diet with a variety of fibrous foods. And listen closely to your body's needs. Gradually increase fiber intake to at least 5 grams per 20 pounds of body weight per day, with an upper limit of 45 grams. For assistance with determining your daily fiber intake, I gave you a couple of links here that you can use to basically, they're fiber counters, and you can learn how to you can basically look at your diet and see how much fiber you're getting. There's actually apps that you can put on your phone too, that you can just speak the food into it and how much you had, and it'll tell you how much fiber you're getting. So the 3rd step is fiber supplementation. And so fiber can be taken from the food So even if you're allergic to a food or you have a problem with a food, sometimes you can still take in the fiber from that food. So if for any reason you just can't get enough fiber in your diet, or if your body can't handle the fiber that's in the food that you have available, then listen closely to your body's needs and supplement appropriately. In my home, we have several different wide spectrum fiber supplements that we like for different recipes and reasons. We can use any mixture of gluten-free oat fiber, apple pectin, rice bran, and a variety of ground or whole seeds and nuts. We also will make delicious soups and dehydrated sprouted crackers and breads with all that fiber that comes out of the juicer when you're juicing vegetables. So we'll use all of that. I just want to encourage you to take in a rotation of fiber, supplemental fiber or fiber from your food. And all that variety of fibers is going to grow all those 160 species that you need to be healthy. Think of your probiotics like your most beloved pets. And the fiber you take in is the pet food. And that is the material that they're going to use to create all those neurotransmitters that help you feel satisfied and happy. All right? Your pets are going to turn the fiber you take in into your happiness and satisfaction. That's what you need to know. The greater the variety of fibers you take in, the healthier and the wider the diversity of your gut bacteria, and the more functional your microbiome will become. So a great prebiotic is one that's going to contain several soluble fibers. It's going to very likely contain inulin. Inulin is generally well tolerated, and it's going to depend on the person, but it might need to contain very little to no fructooligosaccharides, or FOS, because there are an increasing number of disease-causing pathogenic bacteria that have learned to thrive on fructooligosaccharides. So if a prebiotic causes gas or bloating, that is not a good sign. So consider either decreasing the dosage or finding another that works really well for you. So I had a yoga teacher years ago that used to say, get the hint instead of the hammer. And what I will tell you is that's true for all of what I'm saying right now. I mean, some of you will have problems with certain foods. Some of you won't be able to take in real rough fiber quite yet. You have to listen to your body, right? I want you to listen to your body more than you listen to your neighbor. I want you to test and see what can your body do. And if you're noting that you're having an effect from a certain food, then don't take in that food. If a certain type of fiber gets you, don't take in that food or that fiber supplement. If it's causing symptoms, that's your body talking to you. And your body gets to vote. So some people say to me, all that fiber and food, it sounds like so much work. Well, to those, I quote the wise Lord Edward Stanley. And he said that those who think they have no time for healthy eating will sooner or later have to find time for illness. So I want you to be very proactive with the foods that you're focusing on. I want you to take in a wide variety of foods. I want you to take in especially a wide base of vegetables. That's what's going to give you the most amazing variety of fibers, but also the nuts and seeds. You want to take in some protein foods as well. And, you know, I'm beginning to get a bigger appreciation of what the fruits can do for us. So if your body can handle the sugar of fruit, if you're moving enough and can take in that simple carbohydrate, then the fruits also can be an amazing source of fibers. There's Lord Edward with his quote. And okay, so what else can we do? You can be physically active, and you know, you want to be appropriate. What's appropriate for your body in taking care of yourself, and what kind of movement is going to be the best for you? All right. Some people may get plenty of exercise just by lifting up their arms or shuffling their feet on the floor. Whereas for me, that's not nearly enough. I have to really get out there and move for this body to be healthy. Get enough sleep. This is a big, big issue, and getting enough sleep is so important. And I'm beginning to realize also that those that I'm working with that are very, very ill get a tremendous amount of assistance by extending the amount of sleep that they get. Instead of the 8 hours that we often talk about as being a minimum, because without them, you can't actually produce your neurotransmitters properly. The 6 to the 8 hours, most of our neurotransmitter replacing. But it turns out that if you rest for 10 to 12 hours, just stop moving, lay down and stay still, hydrate. When you do get up and move, you've got another 12 hours to do that. Then take in really fresh, wonderful, wholesome foods that are good to you, and move your body, and then rest. And what can happen is the body can repair itself. Also, managing stress is very, very important, as you can imagine, because how we think affects who lives inside of us. And who lives inside of us affects who we are. So what else can we do? We can practice good hygiene. We talked about this, I believe, in the first video, how important that is. You want to wash your hands with mild soap, and take good care of your teeth. You know, I have a system here in the office I've put together for people that have periodontal disease. If you've got inflammation or pockets that are going on in your mouth, I have a procedure. All you have to do is contact the office, tell whoever answers your email, you're just looking for the oral health procedure, and we're happy to send that out to you. It will reverse the pockets. And you want to take in great nutrition. Hopefully it's nutrition that has been designed for you. You're taking in the amounts and the nutrients that your body actually needs. If you're unsure, you know, and the other thing is, if you're taking nutrition from, that you're buying nutrition online, make sure that wherever you're getting it from has quality control studies that are being done. Make sure you're getting the best quality, because the difference is amazing. Also, you want to make great bowel movements. Bowel movements happen 2 to 3 times a day in anyone that's 2 years old or older. 2 to 3 times a day. They are wide, long, fluffy, and they leave the body very easily. They don't make much of a mess, and there's no blood or mucus associated. That's what we want. So I actually have a little book that I put together for you. If you've come here, if you've registered and come live to this talk, then you will be getting a little booklet. It's called Simple Steps for Creating Healthy Bowel Movements, and it will be arriving in your inbox next week. So you know, Deepak Chopra is one of my heroes. I had the great opportunity and luck to spend an afternoon with him, and he completely changed my understanding of how the body works. In fact, over 20 years ago, he was discussing how the mind is not the place where all the thought and memory resides. He explained that the body has all the right chemistry to hold thought and memory in our tissues as well as in the brain. He said there's really no mind-body connection because there's no separation. It's all one system. He also said that no matter how much it gets abused, the body can restore balance. The first rule is to stop interfering with nature. So I am going to open up to questions at this point. Okay, so we have Kate asking this. Oh, she's saying it's such great info and so well presented. Unfortunately, she's gone to another meeting. Okay. Kate is looking forward to getting the book. All right, I'll wait for more responses to this, and I'm going to go over to the emails that were sent in. So here I have one. My son has been suffering with attention deficit disorder and depression since he was a young child. Why haven't the doctors ever told me about this information? Oh dear. Well, partly in that this is very new information. We are learning about this fast and furious as we speak. Just in preparing for this talk, the publications that were coming in while I was actually in the midst of doing this talk were amazing. So the research is coming in fast and furious. We're learning about the gut-brain axis, and your physicians may not have known when you visited them or may not be paying attention to this information. So now you know. And this is something that's very, very important. We all need to get a sense of this. And it gets tricky. A lot of people think, well, I'll just go and get my neurotransmitters measured, and then what will happen is I can, maybe balance them. Just take something that would increase one or increase the other. Well, it's complicated because, for instance, if we take GABA, we take too much of it, it actually decreases the number of receptors we have for it. And some of the people that have a lot of glutamate also have decreased number of receptors, or maybe it's a person that already has a lot of receptors. So a very highly intelligent person with a ton of receptors, a young person that has SIBO, is going to really, really have a lot of anxiety. So that's what I'm talking about. This is an interesting one. This is a response to all the talk about anxiety raising in the workplace, I believe. This is someone saying that anxiety is also increasing in the schools, and that there's severe high anxiety in schools that's being seen, and children are needed to be medicated. So I know that to be true. In fact, I know that some of the schools are requiring that children be put on SSRIs, and that is deeply affecting brain chemistry. I mean, it's a judgment call, obviously, for parents as to whether they're going to give medications to their children or not. But that is, it's a problem because you're affecting the serotonin dopamine balance, and it also seems to be affecting the microflora or the microbiome, which then in turn will affect all of the other neurotransmitters and hormones. So it's not necessarily the best thing in the world. We would like for the children to be okay, but then I can understand the school's point of view in the problem that you've raised, Sharon, because the schools are in a situation where they have children that are off the wall. And I mean, even now we have homicides that are happening. Maybe it's time to take care of balancing the microbiome in our children and paying attention to the data that's coming out now. Well, so this is Mary that's writing in. She wants to know what's the best way to decrease glutamate. Well, you know that piece that I gave you at the very end, the 3 steps to balancing the microbiome? That's what I want to tell you. Because even if you take GABA, and GABA is one of the answers. I mean, it can be that a GABA precursor, and we do have GABA precursor here in this office, and it can be helpful in small quantities. In large quantities, it can be addicting, and taking straight up GABA can cause more problems than it's worth. What we really need to do is get the gut balanced, get the microbiome together. That is my biggest message for you right now. George says, I can't take in fiber at all. What am I going to do? Okay, George, I'll take you through it. All right. And I'm sure that what you're saying to me is that your need for fiber is superseded by whatever happens when you take in fiber. You're having some kind of an irritable bowel type of issue. But your question is short and sweet, and I appreciate it. What we do is we start off by allowing you to have a wide variety of flora. And you want to make sure that you're getting the right strains of flora, and there's certain ones that we definitely want to start with. Now, which ones we start with are going to be determined by kind of like your history, your medical history. Did your irritable bowel syndrome start when you had a colonoscopy or a use of antibiotics? Did you have it all your life? Was there a particular disease that you had that caused it? Did you get food poisoning and then have a problem? So these are going to answer the question, which probiotic and why. And so that, we start off that way and start getting good bugs in your system and widening out the diversity so the bugs can start doing the work that they're supposed to be doing, okay? So it's like you've got a baseball team. Your baseball team, and actually, I don't remember how many people are on a baseball team, but your microbiome team has 160 species. Honestly, it doesn't particularly matter whether you have the same species on a particular position on your team as I do, or anybody else in your family or community. There are a lot of different species that can work in those different positions. So it's almost like you have a bunch of baseball teams, and you've got one baseball team, you've got a second baseman from Mexico, and you have another team with a second baseman from Texas, and you've got another one with a Canadian on second base. Okay, so yeah, Canadians play baseball. And so we can see that it doesn't matter where the second baseman comes from, as long as you've got a good baseman, you can have a good team. And the same is true for your microbiome. It's like 160 positions on your team. And if you don't have all of those, you're going to have trouble, and you're going to have hyperreactions and more inflammation across the board. So what we're going to do is add back the good bacteria to your gut. This is not going to cause a problem, especially if we start with the right ones. And then what we do is we build up that microbiome until it's really diverse. And what we can do with somebody that's super sensitive, like it sounds like you are, George, is to give what I talked about before, the prebiotics. There's certain prebiotics that are generally very well tolerated. There's soluble fiber. It usually comes as a powder, and you mix it up in water. It should taste a little good. I mean, it'll have a slight sweet flavor. And we start that way, and we can also use herbs that are very calming and soothing to the gut at the same time. So this is what we're going to do to rebuild it. And then we're going to put in the bacteria of an infant and restart up that gut. Now, if you've got a buildup of bad guys, then what we're going to need to do is do something called a biofilm turnover. And in a biofilm turnover, what we do is use proteolytic and plant enzymes to remove the old biofilm and replace it with a new one while putting in all the good bugs. So it builds up into a new system, and you're going to continue and develop that, that rich diversity of your microbiome by giving it different fibers. At that point, you're going to be able to take in fiber. You're going to be able to take in more foods. Foods that used to kill you are not going to anymore. So George, great question. Thank you so much. That really talks about rebuilding the biome. So I want to invite you, if you're having problems, if you have a loved one that's having an issue, don't hesitate to contact the office. Anyone watching this video has a free 15-minute consult. Don't hesitate to call the office. Even if you just have some questions, we can sit down and talk about that. I'll give you a few minutes of my time. Okay? And you are welcome to also ask your questions by email. So there's the email address. And take care, everyone. Bye-bye. Till next time.